let's have a look at this. We want the point of intersection between a line and a sphere. Well, let's put that sphere into its vector equation first. So remember, we're kind of saying the distance between that point on the edge of the sphere and the center. And the center we can read off -2, 3, -4. So that distance is the, yep, got that right, okay, good, is the radius, is equal to the radius. Now remember, that's the radius squared, so I'll put the square root of that in. Okay, and then if you think of any point here, the x value would be 4 minus, or I'll just put it in as a point. So any point there would be, and I'll pop it in here because that's the point we're looking for, where it intersects with this sphere. So 4 minus 5, 1 plus lambda of 12, 13 minus 11. So just reading off these numbers. Okay, so that point, you could think of that as a point, and the difference, so the distance between that point and the center, because I'm looking for that point of intersection, so it has to lie on the edge of that, on the sphere. So that should be root 125. So if we have a look at that, look across at the x's, we would have 6 because we've got a 4, and then we've got a -2, so plus 4. Did I just write that wrong? Yes, I did, didn't I? So that should be a 2, not a 12. Okay, that's better. So that's a 213 minus 11. So we've got a 4 plus a 2 is a 6, plus 2 pi, so 2, I always call that pi, 2 lambda. And then looking at the y's, we've got a -5 minus 3, so we've got a -8, and then a 13 lambda, and then a 1, so plus a 4, 5 minus 11 lambda. So that, the distance when we put that together has to be root 125. All right, so how about we have a look at that distance? So if I square both sides, and I don't need the square root, so I'm saying 6 plus 2 lambda squared plus -8 plus 13 lambda squared plus 5 minus 11 lambda squared, all of that has to equal 125. So if we expand that, so I might just, hopefully you've got that down, I'll rub that out so we've got a bit of room there. Okay, let's expand that out. I wonder if I could make that a thicker pen would help. All right, I'm going to go over right over here because it's going to take a bit of room. So 6 sixes, we've got 36, double the 6 2s are 12, so 24 lambda, and we've got 4 lambda squareds, 8 8's 64, 13 times 8, and it's a negative, and we're doubling it, so 104 becomes 208 lambda, 13 squared is 169 lambda squared. Alright, 5 squared is 25, 11 fives, and it's a negative, and we're doubling, so we get 55, 110 lambda, and then 11 11's 121, I think. Okay, so let's put all those together. So if we put our lambda squareds together first, let's have a look at our lambda squared. So we've got 4 lambda squareds, 169 lambda squareds, 121 lambda squareds, which is 294 lambda squareds. If we're looking at our lambdas, we've got 24 lambdas minus 208 lambdas minus 110 lambdas. So we've got negative 294 lambda, which works out nicely. If we look at our constants, we've got 36, 64, 25, which does give us the 125, which is on the other side as well. So that cancels and we get a 0. So let's factorize, and we can see then that lambda could be 0 or 1 to make this work. So let's try lambda equals 0 and then lambda equals 1. Okay, so when, get rid of that. So when our lambda equals 0, let's put that in our line to see what point that is. So that gives us just our 4 minus 5, 1 point. What about when lambda equals 1? We'll have a 4 plus 2, we'll have a minus 5 plus 13. So just looking at the x's, then the y's, then the z's, and a 1 minus 11. So that's going to give us a 6, 8 minus 10. So there looks like there's 2 points of intersection between that line and the sphere.